Hello team! We are back today talking about DNA. This is our plan for this video. Read the whole handout before doing this, and I highly recommend also watching those videos if you're confused on anything. With this specific topic, 3D is better than 2D. So I selected some specific videos with 3D stuff. There's more and less realistic animations, and I gave you options. There's also some terrible music videos. If you fall down the hole of science videos, just be warned that there are a lot of very, very awkward white boys rapping who are like 40-something. So you have been warned. Okay, so back on topic. PEQ1, and then we're going to talk about replication. I got a bunch of questions about leading versus lagging strands and all of the different moving pieces with lagging strands, so I'm going to focus on that. I also got a lot of questions about all of the different bits involved with transcription and start and stop, as opposed to the middle. So I'm not actually going to talk about the middle, I'm just going to talk about initiation and termination. And I got two people asking about translation, specifically tRNA sites in the ribosome. And I've got a really clever mnemonic for that. It's in the vocab words, but I will just give it to you in a moment of clarity at the very end. Yeah, there are way too many vocab words for this week. I recognize that. I highly recommend that you play word scramble with yourself. So either if you have a printer, print them out, cut them up, and try to assemble them in groups, in timelines, or copy them down on pieces and slips of paper and draw them, or, write a paragraph about them and then send them to me. Wink, wink, nudge, nudge. And, okay, so let's get into it, hey? So, PEQ1. In PEQ1, you are studying a newly discovered diploid organism. You discover that the percentage of cytosine in the DNA of the organism is 18%. How much adenine will you find in the DNA? So, you know what C is, but you don't know what A is, and you want to figure out what A is. Let's talk about some basic qualities of DNA. DNA has A, C, T, and G. A and T always match, and C and G always match, which means that the numbers of A you have will match the numbers of T you have, and the numbers of C you have will match the numbers of G you have. So in this scenario, we know that 18% of the organism is C, which means that the another 18% is G. Together, they are 36%. That means that the remaining A plus T is going to all add up to 100%, which means that this must be 64, right? Yeah, I did math. Okay, so that means that the remaining 64%, which is A plus T, that will add up to 100. So the question is not A plus T, the question is just A. What's the percentage of just A? So the percentage of just A is going to be half of that, which is going to be 32%. So that's your answer for question 1A. So that's 1A. 1B just asks, will that change in a diploid organism? Sorry, haploid organism. We've been in diploid, now we're in haploid. So take a moment. Will it change in haploid? So this process of the A's and T's matching and the C's and G's matching, so that has to do with just being double-stranded. All double-stranded DNA has this lovely percentage quality. So a haploid organism, that DNA is still double-stranded. So the result is not going to change at all in a haploid gamete, say. is more interesting. In C, now we're talking about RNA instead of DNA. RNA is not double-stranded. Because it's not double-stranded, that means that there's no base pairing. And because there's no more base pairs, A is no longer predictive of T, C is no longer predictive of G, and you can't work out any of these ratios based on one or the other. All right, so now let's talk about replication.